Hello everyone, thank you very much for watching this video. I'm Mr. Matt and this is Dr. Tot. Dr. Tot, you want a cookie? Start class? Very good. Welcome to Algebra 2. This is quick drill set B to graphing quadratics. If you have any questions at any point, then please drop them in the comment section below and I'll respond as soon as possible, usually within 24 hours. We're going to go through 3 separate presentations of quadratic equations. So your teacher may present the quadratic equation in either the standard form, intercept form, or vertex form, and there are 3 different approaches. They're very similar to each other, but it can be a little bit confusing going from one approach to another, so we're going to look at all 3 of those different formats. And if there's not going to be any time, I'm not going to give you any time during this recording or in the recording to do the problem, so I want you to pause the video before each question, attempt the question, and then unpause it to see the solution. So let me go ahead and share my screen with you. The document for this lesson is available on Certified Learning Center's website. The link and directions to find directions to find those documents in either the PDF or Word format is in the description. Link to this link is in the description of this video. Make sure that you're looking at document 2104-8. So each document has a unique identification number called the reference number. So as long as you have that number in the upper right hand corner, you know that you're all good and you're looking at the right document. So I'd like you to pause the video and sketch a graph of y is equal to negative 3x squared minus 6x plus 5. So we can first of all notice that this is in the standard form of a quadratic. The standard form is y is equal to ax squared minus bx plus c. When examining the standard form, the characteristics or information, visual information about the graph is not readily apparent in the standard form. So we need to use an expression to try and understand what this is all telling us. That expression is negative b over 2a. That's going to give you what's called the axis of symmetry. So every quadratic has this characteristic U shape. And so obviously the quadratic equation is symmetric around a central value. So you can see here that this graph is symmetric around the equation x is equal to 0. That's not always the case. It can be shifted left, right, up, down. But in any case, you can use this expression to find the x-coordinate of the vertex because the axis of symmetry is always going to fall on the same or be the equation of the x-coordinate. It's going to be x is equal to the x-coordinate of the vertex. Then you can go from there by testing a value a little bit to the left, a little bit to the right, and then connecting the 3 dots together to shape your overall graph. So let's insert the values here. Our b value is negative 6, our a value is negative 3. So negative b is going to be a negative 6, don't forget that extra negative, divided by 2 times negative 3. A negative 6 is going to be a positive 6. 2 times negative 3 is a negative 6. 6 divided by negative 6 is negative 1. So the axis of symmetry of this graph occurs at x is equal to negative 1. So I'm going to go ahead and just draw in an x and y axis. And so at x is equal to negative 1, I'm going to put a dashed line to represent the axis of symmetry. So I know that the vertex has to occur somewhere along this vertical line. When testing values, I'm definitely therefore interested in negative 1, where the vertex is going to occur. And then I'm also going to test two values, one a little bit to the left, maybe -2, and one a little bit to the right, maybe 0. Evaluating -2 into this equation, we're going to have -3 times -2 squared minus 6 times -2 plus 5. -2 squared is a +4, so we're going to get, -3 times +4. -6 times -2 is going to be a +12, and then we're going to have plus 5. -3 times -4 is a -12, so we're going to get -12 plus 12 plus 5. -12 and +12 will cancel to 0, leaving us with just 5. So when x is equal to -2, y is equal to +5. If we evaluate -1, we're going to have -3 times -1 quantity squared minus 6 times -1 plus 5. -1 squared is +1, so we're going to have -3 times +1. -6 times -1 is going to be a +6, and then we still have that plus 5. -3 times 1 is -3, so we're going to have -3 plus 6 plus 5. 6 plus 5 is 11. 11 minus 3 is going to be +8. So when x is equal to -1, y is equal to +8. And lastly, if we evaluate 0, this one's going to be simpler because 0 is the ultimate nullifier, so a lot of things are going to nullify out. So we're going to have -3 times 0 squared minus 6 times 0 plus 5. 0 squared is 0, so we're going to have -3 times 0. -6 times 0 is 0, so that's going to turn to 0. And then we still have that plus 5. -3 times 0 is 0, so this is going to turn into 0 plus 5, which is obviously 5. Notice that this makes sense with this being symmetric because we have values repeating that are equal distance from the vertex. -2 is 1 unit to the left from the vertex x-coordinate of the vertex -1. 0 is 1 unit to the right of the x-coordinate of the vertex -1. So these two values are the same, and that makes sense if the function overall is symmetric, which we know that all quadratic functions are. So let's go ahead and plot these points. Let me get a different color. So at x is equal to -2, we're at 5. At x is equal to -1, we're at 8. And at 0, we're at 5. Now, it might concern you why your middle value is above the other two points to the left and the right. But remember, our a value, our leading coefficient here is negative. This whole thing is expected to open downward. So this goes along with what we would expect. So if we just connect these points, then our graph would look something like this. And I have to apologize. There's a reason why I'm a math and science teacher, not an artist. So please bear with me with my drawings. If you have any questions, please let me know. Otherwise, please pause the video and sketch a graph of y is equal to -2x squared plus 8x minus 3. So again, this is in standard form, ax squared plus bx plus c. So b is +8, a is -2. So evaluating the expression -b over 2a, we're going to have -8 over 2 times -2. That's going to be -8 over -4, which is a +2. So the axis of symmetry occurs at +2. So I'm just going to go ahead and draw in an x and a y axis. And then at x is equal to +2, I'm going to draw in my axis of symmetry. I know that the vertex has to occur somewhere along this vertical line. So when I'm testing values, I'm definitely interested in x is equal to +2, but I want a value a little bit to the left of that. That's going to be maybe x is equal to +1. And I want a value, a little bit to the left of that is +1. A little bit to the right of that would be +3. So evaluating 1, we're going to have -2 times 1 squared plus 8 times 1 minus 3. 1 squared is 1. 1 times negative 2 is negative 2. 8 times 1 is 8. And then we have that minus 3. Negative 2 and negative 3 will make a negative 5. Negative 5 plus a positive 8 is going to give us a negative 3. And let me just make sure. I'm sorry. Yeah, I just wanted to make sure nothing happened there. So we should have a negative 5 and a positive 8 will give us a positive 3. So at x is equal to 1, y is equal to 3. Let's evaluate x is equal to positive 2. So we're going to have negative 2 times 2 squared plus 8 times 2 minus 3. 2 squared is 4. 4 times negative 2 is a negative 8. 8 times 2 is a positive 16. And then we have that negative 3 carry on. The negative 8 and the negative 3 will combine together to get a negative 11. Negative 11 and a positive 16 will give us a positive 5. So when x is equal to 2, y is equal to positive 5. And lastly, if we evaluate positive 3, we're going to get negative 2 times 3 squared plus 8 times 3 minus 3. 3 squared is 9. 9 times negative 2 is a negative 18. 8 times 3 is 24. And then we have a minus 3. Negative 18 and a negative 3 will make a negative 21. Negative 21 and positive 24 will give us a positive 3. Again, because we have points equal distance from the vertex, we do see this characteristic repetition of y values, because the y values are going to be equal when the x coordinates are equal distance from the vertex. Because overall, remember, these equations are symmetric. So plotting these points, at positive 1 we're at positive 3, at positive 2 we're at positive 5, and at positive 3 we're at positive 3. So again, the leading coefficient is negative, so we would expect this graph to open downward. So we could sketch it to look something like this. Please pause the video and sketch the graph of the function y is equal to negative 4x squared minus 32x plus 3. So again, we're in standard form, ax squared plus bx plus c. So if we evaluate the expression negative b over 2a, we're going to have a negative 32. Quantity divided by 2 times negative 4. That's going to be a positive 32 divided by a negative 8. That's going to give us a negative 4. So at x is equal to negative 4, we have our axis of symmetry. Notice that if I know the graph is skewed to the left, I offset my axes a little bit. So I just drew it a little bit to the right, so I have more room on the negative quadrants. So at x is equal to negative 4, we have our axis of symmetry. So I'm definitely interested in what the output is at x is equal to 4, but I'm going to test a value a little bit to the left of that, negative 4. So maybe negative 5, and a little bit to the right of that, so maybe negative 3. So at negative 5, we're going to have negative 4 times negative 5 squared minus 32 times negative 5 plus 3. Negative 5 squared is 25. 25 times negative 4 is going to be a negative 100. 32 times 5. I'll show you a little mental math trick. If you have 5 times 32, you can break 32 up. 32 is the more complicated number format here. So we could think about that as 30 plus 2. And then you can just distribute and add the results. 30 times 5 is 150. 5 times 2 is 10. 150 plus 10 is 160. So you can break more complex numbers up by thinking of them as the sum of their individual hundreds, tens, and ones units, or whatever digits the number actually has. Here it had tens and ones digits. So negative 32 times negative 5 is going to be a positive 160, and then we have plus 3. Negative 100 plus 160 is going to be a positive 60. Positive 60 plus 3 is a positive 63. So at x is equal to negative 5, we're going to be at positive 63. Substituting in negative 4, we have negative 4 times negative 4 squared minus 32 times negative 4 plus 3. Negative 4 squared is 16. 16 times negative 4 is going to be a negative 64. 32 times 4, we can think about that. 32 times, or 4 times 32, I can think of as 4 times 30 plus 2. 4 times 30 is 120. 4 times 2 is 8. 120 plus 8 is 128. So this is going to be plus 128. And then plus 3. So we're going to have negative 64 plus 128 plus 3 is going to give me 67. And then lastly, we have when x is equal to negative 3, negative 4 times negative 3 squared minus 32 times negative 3 plus 3. Negative 3 squared is positive 9. Positive 9 times negative 4 is going to be a negative 36. Negative 32 times negative 3, that's going to be a positive 96. And then we have a plus 3, so we're going to have negative 36 plus 96 plus 3, that gives us 63. And that checks out because we see this characteristic symmetric form occurring. We have the repetition of those y units when the x values are equidistant from the vertex. So at negative 5, we're at 63. I'm going to count by 20s on the y. So let's say that this is 20. Well, technically I'm counting by tens. I'm just skipping over units. So just for space's sake, I'm counting by ones on the x-axis, but I'm counting by tens on the y just for space. So at negative 5, I'm at 63. So I'm going to be about here. At negative 4, I'm at 67, so maybe just a little bit above that. At negative 3, I'm at 63, so again right there. So our graph will look something like this. Because those three values are so close to each other, in order to get that really more accurate, in order to get that to be a little bit more accurate than what it is, you need those points to be spaced out a little bit more. But for a sketch, this is good enough. Okay, take a few moments and sketch a graph in this intercept form equation. Y is equal to negative 2 times the quantity x plus 2 times the quantity x minus 5. So as I said, this is in the intercept form, which is y is equal to a times x minus p times x minus q, where p comma q are x-intercepts. Sorry, Dr. Todd has some itchy ears apparently. He's scratching, Dr. Todd. So p and q, notice they're the opposite signs than what's listed in the equation. Positive p and positive q are x-intercepts of the graph. Also, you need to know that the vertex occurs between the x-intercepts. So in other words, it's the average of the x-coordinates. Remember, an average is the sum divided by the number of terms. So if you take the x-coordinates of the two x-intercepts, you can find the distance between them, and you can find what value the x-coordinate of the vertex lies on. So here, p is positive 2, so negative p would be negative 2. So our x-intercepts occur at negative 2 and positive 5. Remember that it's opposite common sense, so you have to switch the sign around. So at negative 2 and at positive 5, we have x-intercepts. If I take 5 minus negative 2, I'm trying to find the difference between the two x-intercepts. So final minus initial. 5 minus negative 2, that's the same thing as 5 plus 2, which is 7. So notice that this has a unit, there's 7 units in between these two x-intercepts. So if I find the average, 7 divided by 2, and go 3.5 units in between these 2 points, I'll have the x-coordinate of the vertex. So if I go 1, 2, 3.5, this right here is the axis of symmetry. That's at x is equal to 1.5. So a little bit tricky, but this guy is right in the middle of the two intercepts. So when I'm testing values, I'm definitely interested in 1.5, but I'm also going to do a point a little bit to the left, so let me say 0, and a point a little bit to the right, let me say 3. So evaluating for 0, I'm going to have negative 2 times 0 plus 2 times 0 minus 5. That's going to be negative 2 times 2 times negative 5. That's going to be negative 2 times 2 is a negative 4. Negative 4 times 5 is a positive 20. If evaluating at 1.5, now I'm going to have negative 2 times 1.5 plus 2 times 1.5 minus 5. 1.5 plus 2 is 3.5, so I'm going to have negative 2 times 3.5. 1.5 minus 5 is going to be a negative 3.5. Let me just confirm that. Yep. So minus negative 3.5. So negative 3.5 times 3.5 times a negative 2 is going to give me a positive 24.5. And lastly, I'm going to evaluate x is equal to 3. So I'm going to have negative 2 times 3 plus 2 times 3 minus 5. So that's going to be negative 2 times 5 times negative 2. And that's going to give me positive 20. So when x is equal to 2, y is equal to 20. When x is equal to 1.5, y is equal to 24.5. When x is equal to 3, y is equal to 20. So now I can plot all these points, and again I'm going to count by a different value. Let me count by 10 for every 3. So at x is equal to 0, y is equal to 20. So we're right here. When x is equal to 1.5, we're at 24.5. So this is just a sketch, so you don't have to be super detailed about it. It's about right there. And at 3, we're at 20. So we can connect these points together and sketch out our graph. Take a few moments and sketch the graph. Y is equal to negative 3 times x plus 3 times x minus 4. So we can tell here that our x-intercepts occur at x is equal to negative 3 and x is equal to positive 4. So I'm just going to list those intercepts or plot those intercepts. So we're at negative 3 and we're at positive 4. If I take 4 minus negative 3, doing final minus initial, I'm going to get 7. So again, I have 7 divided by 2. That's an average of 3.5. So the vertex, or the axis of symmetry, occurs 3.5 units away from either intercept. That's where the middle line is going to be. So if we go 1, 2, 3.5, x is equal to 1/2 is the axis of symmetry here. So I'm definitely going to investigate what the output is at 1/2 or 0.5. But let me also test the values of 0 and the values of 1, just to get two other points to the left and to the right. So evaluating 0, I'm going to have -3 times 0 plus 3 times 0 minus 4. That's going to be -3 times 3 times -4. That's going to be -3 times 3 is -9. -9 times -4 is going to be a +36. For 1/2, I'm going to have -3 times 0.5 plus 3 times 0.5 minus 4. That's going to be -3 times 3.5 times, oops, excuse me, not 0, 0.5 minus 4. 0.5 minus 4 is going to be a -3.5. And so if we do -3 times 3.5 times -3.5, we're going to get +36.75. And then lastly, let's evaluate when x is equal to 1. We're going to have 3 times 1 plus 3 times 1 minus 4. So that's going to be -3 times 4 times -3. So that's going to be -3 times 4 is a -12. -12 times -3 is going to be a +36. So again, just as we expect, we have this symmetric repetition of outputs occurring when x is equidistant from the vertex. So when x is 0, we're at 36. I'm going to just, again, do some odd intervals here just for space's sake. So we're at 36 at x is equal to 0, so that would be right here. We're at 36.75 at 1/2, so just barely above that. Let me do a different color. So we're right here, just a little bit above that, and then at 1 we're at 36. So we can connect these 3 points together. And you could evaluate points that are a little bit farther out if you wanted to get an exact value or exact graph here, but I just asked you to sketch. So that's okay. These are the 3 points just to make it clear. Take a few moments and sketch a graph of -5 times x plus 1 times x plus 2. So here we can tell that the x-intercepts occur at x is equal to -1 and x is equal to -2. So I'm going to mark this off, count by ones like this here. So we're at -1. Let me use a brighter color. -1 is right here. -2 is right here. So -2 minus a -1. That's the same thing as -2 plus a +1. Oops, sorry, I wanted a highlighter there. Leave the first sign alone, change the operation, change the second sign in order to convert a complex subtraction problem into a simpler to understand problem. So -2 minus -1 is the same thing as -2 plus a +1, and that's going to be -1. So we have a distance of 1 between these two values, so the average is going to be 1/2. So this guy, the axis of symmetry, is going to be 1/2 units to the left and right of either intercept. So this guy right here is going to be x is equal to -1.5 because it's 1/2 to the left of -1, 1/2 to the right of -2. So when evaluating points here, I'm definitely interested in -1.5, but I'm going to look at a point a little bit to the left of that, let's say -3, and a little bit to the right of that, let's say 0. So when x is equal to -3, we're going to get -5 times -3 plus 1 times -3 plus 2. So that's going to be -5 times -2 times -1, and that's going to be a -10. When x is equal to -1.5, we're going to have -5 times -1.5 plus 1 times -1.5 plus 2. That's going to be -5 times -0.5 times +0.5. So in our calculator, -5 times -0.5 times 0.5 is going to be a +1.25. And then evaluating at x is equal to 0, we're going to have -5 times 0 plus 1 times 0 plus 2. So that's going to be -5 times 1 plus 2. That's going to give us a -10. So at x is equal to -3, we're at -10. X is equal to -1.5, we're at 1.25. And when x is equal to when x is equal to 0, y is equal to -10. Excuse me. So let's go ahead and plot those points. 3, we're at, I'm going to count by 5s here. So at x is equal to -3, we're at -10. At x is equal to -1.5, we're at 1.25. So that's going to be, so if this is 5, then we're going to be really close to the x-axis right there. And at 0, x is equal to 0, we're at -10. So connecting these dots together, we're going to get a graph that looks something like this. Now let's look at a few problems in vertex form. So take a few minutes and sketch a graph of y is equal to -2 times the quantity x minus 3 squared plus 2. So vertex form is y is equal to a times x minus h quantity squared plus k. The thing you need to watch out for with vertex form, the x coordinate, or that h value, is opposite common sense. It implicitly has a negative sign attached to it, so it's going to have the opposite sign than what's listed in the actual equation. The y coordinate of k goes with common sense, because notice it has a positive sign attached to it, so that positive sign is not going to affect whatever value the y coordinate of the vertex is. But that negative sign attached to the h is going to affect the x coordinate, the sign of the x coordinate of the vertex. So in looking at this equation, h, we have a -3 value for h, so I need to negate that. So the x coordinate of the vertex is going to be +3, +2. Notice I negated the h value inside of the parentheses. I did not negate the k value that's outside the parentheses. So I can use that by plotting this on a graph. So now I'm at 3, 2, so I'm right here. So I already have my vertex. I just want to evaluate a point to the left and a point to the right. So when x is equal to 2, I'm going to have -2 times 2 minus 3 squared plus 2. That's going to be -2 times 2 minus 3 is -1. -1 squared is going to be +1. Oops. -2 times 1 is -2. -2 plus 2 is 0. So at x is equal to 2, y is equal to 0. Let's evaluate what happens when x is equal to 4. So we're going to have, -2 times 4 minus 3 quantity squared plus 2. That's going to be negative 2 times 4 minus 3 is 1. 1 squared is 1. Plus 2, that's also going to be negative 2 plus 2 is equal to 0. So when x is equal to 2, y is equal to 0. When x is equal to 4, y is equal to 0. So now we have enough information to connect these points together. And so our graph is going to look something like that. Notice it does open down because this a value, that leading a value, is negative. Okay, pause the video, please, and sketch a graph of y is equal to negative 3 times x plus 1 quantity squared minus 6. So we can tell here that the vertex occurs at negative 1 comma negative 6. Notice that the inside h value is negated, the sign is negated, the outside k value, the sign is kept. So let's go ahead and plot that point. Oops, got a little squiggly there. So the vertex, we're at negative 1, negative 6, which is right here. So I'm going to go a little bit to the left and a little bit to the right of negative 1. So I'm going to look at negative 2 and I'm going to look at 0. When x is equal to negative 2, we're going to have negative 3 times negative 2 plus 1 quantity squared minus 6. Negative 2 plus 1 is a negative 1. Negative 1 squared is positive 1. So we're going to have negative 3 times 1 minus 6. Negative 3 times 1 is negative 3. Negative 3 minus 6. If you need to do leave, change, leave the first one alone, change the operation, change the sign. So that's the same thing as negative 3 plus a negative 6, which is going to be negative 9. And at 0, we're going to have negative 3 times 0 plus 1, quantity squared minus 6. 0 plus 1 is 1, so we have negative 3 times 1 minus 6. That's going to be a negative 3 minus 6. Again, that's going to be negative 9. So at x is equal to negative 2, we're at negative 9. That's going to be way down here. And at x is equal to 0, we're at negative 9. That's going to be about there. So I can connect these two dots together, three dots together. And so our graph would open downward and look something like that. Last problem, please take a few moments and sketch a graph to y is equal to negative 4 times x minus 1 quantity squared plus 1. So here we can tell that the vertex is going to occur at positive 1, positive 1. So I can go ahead and draw that or plot that point in. So at 1, 1, we're right there. So I'm going to test a value a little bit to the left and a little bit to the right, maybe 0 and positive 2. So when x is equal to 0, I'm going to have negative 4 times 0 minus 1, not 2, minus 1 quantity squared plus 1. 0 minus 1 is negative 1. Negative 1 squared is positive 1. So this is going to be negative 4 times positive 1 plus 1. Negative 4 times 1 is negative 4. Negative 4 plus 1 is negative 3. When x is equal to positive 2, we're going to have negative 4 times 2 minus 1 squared plus 1. 2 minus 1 is positive 1. Positive 1 squared is still positive 1. So we're going to have negative 4 times positive 1 plus 1. That's going to be negative 4 plus 1, which is also negative 3. So at x is equal to 2, we're at negative 3. So we can connect these three dots together, and we have a sketch of our graph as so. If you have any questions on anything that we've done today in this video, then please let me know in the comment section below. I'm always here for you guys on my social media accounts, so if you have any questions at all, please let me know. If you find these videos helpful, please like, share, and subscribe. But other than that, I hope you have a wonderful day. And Dr. Tot, do you want to say goodbye to everybody? Come on, you got to earn your cookie. Come on, Dr. Tot. You want a cookie? Come on, you want a cookie. Don't act brand new. Come on. You know you want a cookie. You gotta do your job. Say bye. There you go. Very good. Little hard to get him to do that this time. All right, thank you guys very much for watching. Have a wonderful day, and I'll talk to you all soon.